What we're going to learn about in this video is significant figures, also called Sig Figs. You can see here they are lots of fun. Now the definition for Sig Figs is all the digits in a measurement that are known plus one digit that is estimated. So I'll show you examples here. But before I do it, it all boils down to precision. How good is your instrument that you're measuring with? If you're measuring with a ruler that is literally just has the markings for 0 and 1 foot, it's going to be pretty hard to tell exactly how many inches something is if you want to measure in inches. If you have a meter stick with just 0 and 1 meter and no markings in between, it's not the best measuring tool versus a meter stick that has millimeter markings. You're going to be able to get a more precise answer with that. So if you look at this ruler here, if someone were to take this measurement and say, okay, this is 2, that would be a pretty poor job of measuring because this ruler is set up to measure much finer detail than just 2. Let's for the sake of having units here, let's say this is in centimeters. So if this is 2, this is 3, we got 2.5, and you've probably counted 10 markings, or 9, so there's 10 total graduations here. So we got 2.6 and 2.7. So we know that this arrow is between 2.6 and 2.7. So we know for certain that it's 2.6. But we can go further and say it's 2.6 something. So we're estimating how far is it past the 2.6. I might guess 2.67 centimeters. So what we mean here now when we say a measurement that are all digits in a measurement that are known, so we knew 2.6 with certainty, plus 1 that is estimated, here's our estimated digit. Now when we look at this measurement here, there's 1, 2, 3 sig figs, so we'd say there's 3 sig figs in this measurement. So we'll look at a few other examples here. Some practice. See if you can figure out what this measurement is. Pause this for like 10 seconds, quick write down a measurement, see if it is the same as mine. Okay, hopefully you're back here. We got 2 and 3, so we know again that this is 2. We know 2.1, 2.2, 2.3, 2.4. Now, I'm going to say that it's exactly on 2.4. I know my 10th place, so I know 2.1. This ruler gives me markings to the 10th place, to the 0.1 place. So I know this digit with certainty. I need to estimate to the 100th place. I'm going to estimate one number here, so 2.40 centimeters. Now you might be saying, okay, Mr. Zeta, 2.4 and 2.40 are the exact same thing. And mathematically, you are correct. 2.4 and 2.40 will calculate the same way. But in chemistry, if you're reporting this measurement in a scientific paper, other scientists need to know how good your ruler was. If they want to repeat this experiment, they want to make sure they're using the same level of precision with their measurements. So by reporting this 0 here, you're telling other scientists that you have a good enough instrument to be able to report out to the 100th of a centimeter. If you don't put that 0 there, then they're going to think that you don't have that good of a ruler, so that they can repeat it the same way. So again, if you put 2.4 centimeters, that is incorrect. So make sure you get 2.40, and I'll excuse you this one time. Again, this has 3 sig figs because they're all significant in this measurement. Now here, I know that my number, or that my answer is between 2 and 3, so I know 2 with certainty. It's 2 point something. I'm guessing the next digit already. I don't have markings to the 10th of a centimeter here anymore, so I have to guess to the 10th of a centimeter, and again, I'm going to guess maybe like 2.7 centimeters. And this number only has 2 sig figs. So if I report this answer, scientists know that I have a less precise ruler than if I'm reporting my value up here. So that's the difference here. It's important to write the correct number of sig figs to indicate your level of precision on your instrument. So some more practice. Here we've got, and we know it's between 8 and 9. 9's here, 8's down here. So we got 8.5, 8.6, 8.7, 8.8. So I know it's between 8.7 and 8.8. So I know it's 8.7 something. That 8.7 something, I'm going to guess, it looks like it's about halfway. 8.75, and we'll just say milliliters because it looks like a graduated cylinder here. Again, if you have 8.76, you thought it was 8.76, that's fine. I'm not worried about that. What I'm worried about is that you reported this answer to 3 sig figs at this point. Make sure that it's within the ballpark here. If you did 8.74, that's fine too, as long as you're reporting it to 3 sig figs. The next one here, we got 50 and 55. Now this is a little tricky because it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 5 milliliters divided by 10 markings equals a half of a milliliter per marking. So 50 and a half, 51, 51 and a half, 52, 52 and a half, we've got 53 here. So I know it's between 52 and 53. So I'm going to say 52 point something. Now you might be like, wait, but we have 52.5. 0.5 is not 0.1. We need to know to the tenth. We need to know the tenth of a milliliter to be able to estimate out to the hundredth. So I don't know to the tenth of a milliliter with certainty. I only know to the half of a milliliter. So I can't estimate out to the hundredth. So I'm just going to say 52. It looks like it's about 52.7, 52.8 milliliters. And then we'll add our units there. So that one's a little bit tricky because it only goes to the half of a milliliter. You still have to estimate to the tenth because a tenth is a finer measurement than a half. You have to know to the tenth to be able to estimate to the hundredth. This one's kind of a similar scenario. We got 7 and 8. There's 1, 2, 3, 4, 5. So 1 milliliter divided by 5 markings equals 1/5 or 0.2 milliliters. Again, this is not 0.1. We need to know to the 0.1 precision to be able to estimate to the hundredth. So I know that it's 7 point something, but I don't know with certainty because I don't have 0.1 markings. I have 0.2 markings, which isn't low enough. So again, I'd say about 7.4 milliliters. I'm going to let you practice on this. We'll do this in class just to save time on this video, but I would like you to come to class with these done. Okay, now rules for determining sig figs. When I give you a number like 4.520, how many sig figs are in this number? So that's what we're going to get at. So the first rule is all non-zero digits are significant. If it is a number 1 through 9, it's automatically significant. Count it. So I count 1, 2, 3. So the question is this 0 significant? So I have either 3 or 4 sig figs here. The second rule, all zeros are significant except for trailing zeros with no decimal point. So this 0 is a trailing 0, but there is a decimal point. So if it's trailing with no decimal point, it's not significant. So that means that this one must be. So I would have 4 sig figs here. So some examples. We've got some examples here. So before I get to the examples, this rule sounds kind of funny. Here's how I sum it up. Is there a decimal point? If the answer is yes, then trailing zeros count. If the answer is no, then trailing zeros don't count. So here, I've got trailing zeros. Do I have a decimal point? No, I do not. There's no decimal place there. So the trailing zeros don't count. So I do not count these zeros. That is the only significant figure I have, so I have 1 sig fig. Again here, there is no decimal here, so these zeros do not count. They're trailing zeros, Now again, all non-zeros count, so I definitely have 3. There's another little rule here that I'm going to break to you that I don't think I've actually written down. If a 0 is sandwiched between non-zero numbers, it counts. So all 4 of these are significant, but these are trailing with no decimal. So these don't count, these 4 do, so this has 4 sig figs. Here, yes, we do have a decimal. So now these trailing zeros do count. So I have 1, 2, 3, 4, 5 sig figs. Now you might be like, well, this doesn't make sense. Why do these count but these don't? Because you should always ask why. Don't just take these random rules for granted and just start mindlessly doing them. What's the purpose of this? The purpose is that in chemistry, every number is a measurement. It came from a measurement somewhere. If I were taking a measurement and I had a good enough ruler, I could precisely say that my measurement was 2.3000. By reporting these zeros, I'm telling you that I had a really darn good ruler that was able to let me confidently say that it is exactly 2.3000 all the way out to the 10,000th of a, let's say this is a centimeter, if I'm talking about centimeters. If I don't have a very good ruler, this is the only number I know with certainty, and then I just rounded it off because I really don't know these numbers to certainty. To keep moving here, there is a decimal, yes. So all of these count and this count. They're all trailing. So 1, 2, 3, 4, 5 sig figs. And then if you remember back in scientific notation, all scientific notation numbers are significant. And when I say all of them, I mean the ones up here. These don't count. So this is 3 sig figs. All zeros are significant except for, so here's the other ones that aren't significant. Zeros used to indicate place. Leading zeros in front only for numbers less than 1. So what we got here, these are just placeholders. These are the heavy lifters of this measurement. These zeros just kind of hold the place, right? I could get rid of them using scientific notation. So this just has 3 sig figs. So what I mean by that is I could rewrite this as 6.70 times 10 to the minus 1, 2, 3, 4. So I can rewrite it to get rid of it to have 4 sig figs. Same thing, these do not count. They're placeholders between the decimal and the first non-zero. So 1, 2, 3. 3 sig figs. Oh, 3 sig figs. Again, same thing here. 3 sig figs. This is a sandwich 0, so it does count. These are the ones that I get rid of. 3 sig figs. But here, the difference between this number and this one is that these are no longer just placeholders because they're sandwiched between these. These zeros are sandwiched between these, and these are trailing zeros, but there's a decimal, so actually all of them are significant. Sandwiched, sandwiched, trailing with a decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs. So that's a very precise measurement. So general rule, if it's a placeholder, it's not significant. And remember, all digits listed in scientific notation are significant. So 3 sig figs, 2 sig figs, and 3 sig figs. If it's scientific notation and you're counting sig figs, you should be happy on a test because they're about as easy as it gets. You just count them. The last rule is that counting numbers, conversion factors, and defined constants have an infinite number of sig figs. So you ignore them. When you do calculations, you don't have to worry about the sig figs. And what I mean by counting numbers, if I am counting the number of students in class and I find that there's 25 students in class, I know with certainty that there's 25.000000 for as long as I can go students in the class. I can't have 25.0000 and then 1 student, right? That's silly. So if you're counting something, infinite number of sig figs. You can't count how many sig figs it has. Same thing with conversion numbers. They're very precise, so we don't have to worry about them. And that's all we got for sig figs.